Working on another gearbox shaft. This is kind of a small one, 5.5-inch diameter. See how I'm using my Noga Mini Cool. It works really well over here on the lathe. Not a very heavy cut. That's 200 thousandths a pass, 20,000 feed rate. Don't have a whole lot to come off there. I'll give you a little peek at what we're making here. So just starting to get this end roughed in right here. So here's the shaft I'm making right there. It's got a bad fit here. It's got a bad seal groove right there, or a seal journal. It's got a groove bore in it. But this whole fit here is really bad, so we're just making a new shaft. So in case you missed it before, there's my little trick with the Mighty Mag to get shoulder links there. Put your Mighty Mag, butt your scale up on it, and you can get shoulder links there. Doesn't matter if it's imperial or metric. Use whatever rule you want. You can line it up, and then you can verify these with a depth mic. Okay, coming from the end up to the shoulder, but this gets you roughed in really, really close. You know, or you can use calipers if you want to, but that's just a handy little thing, is to use the Mighty Mag there. And do the same thing on the other end here. Okay. It holds pretty good. Squares up nice, and then you can see we've got a shoulder length there of 12.25 inches. And again, you can verify that, you know, with other measuring needs. All right, so I just wanted to kind of show that. Got some more coat flex couplings there I'm working on. Got some retainer nuts in these boxes here for a couple of the shafts I'll show you. So here's two more that I'm in the process on now. I've got this one's roughed in, and then this one here I haven't started roughing it in yet, but we've got it. A piece of 4140 there. Okay, that one's going to be for this other big one. These are in really rough shape. They're all worn down. They need to be replaced. This is the hub for the pinion gear. The pinion bolts to that, and this fits on this shaft right here. And I had to go in there and true this bore up because it was so loose, it was flopping around on there. So we had to take a 1/16 out of this bore, and then I'll match the new shaft for that. And these threads here are where all the bearing retainer nuts goes on. Alright, so that's just a little bit of work that I got going on this week. Just kind of routine stuff. So maybe I'll give you a final shot of what that shaft looks like when I get it finished.
Alright, so why is this discolored right here? What is that?
Well, that's the fretting, and it's caused because it's a loose fit. This is loose, and the coupling's loose. So you can take a little measurement right here. This should all be a nominal size from here to here, because this is your seal fit, this is your shaft fit for your coupling or whatever goes on there. So this should be your nominal size, 4.5 inches. Okay, so that's pretty good right there. You come down here on the end and look. You see how much smaller it is? It's over 30 thousandths.
Hey.
Undersized right there.
So and why wouldn't you just weld that up and turn it back down?
Well, from a machinist standpoint, it's much easier just to machine one instead of welding it up. But when you got stock on hand or just a day out, then just order a piece of stock and machine a new one. That takes a lot of labor to weld this up and then have to turn it down. One of the cases where I may weld this up and machine it would be sort of like a late night weekend rush job scenario where you don't have a piece of stock and you've got to get this thing done the same exact night. Then maybe go ahead and set this up, clean it real good, undercut it, and then run beads, and you'll be there for hours welding it up and then machine it back.
So as far as man hours go, it would be better to just cut a clean piece of stock.
Yes, it would be, especially for a simple shaft like this. You know, you got 1, 2, 3, 5 journals and 2 keyways on there. So, I mean, the same amount of time you can make a shaft it's going to take you to weld this up and machine it.
Okay, well, thanks.
I'm making my finished passes on that's the bearing journal there. I've already got the gear journal finished up. And what I like to do is leave approximately 60 thousandths, and then I'll make like 20 thousandths passes. And every time I make a pass, I mic it and I compare it to what I measured the last time and see if what I'm dialing in, you know, is what's coming off the material every time. Usually once you get dialed in and you're taking equal depth cuts, like 20 thousandths a pass, everything will work out for you as long as you dial that correctly on the line. So this should leave me with one more finished pass, about another 20 thousandths to bring it down to our proper fit that we need. So we're getting ready to cut the radiuses there. I was going to show you something else that I've done on this lathe, my little modification, little machinist hack here. I added a travel dial here. Now I've done this a while back and I use it sometimes, but this is where the thread dial goes. I couldn't think of what it was called for a sec. The threading dial goes on this stud right here and tighten up with a nut. So I made this plate and a travel dial. All right, and I can use that for pretty accurate linear movements. So I've already got my offset right there that I want. From this edge, I want the edge of the radius to be 2.665. So I've got a 0 set here. So let's come on back. Reset a 0. All right, that'll be our 0, 0, 0. All right, then we'll go ahead and crank it on down. We'll go to this 0 here because I've already measured it. All right, there we go. There's our 1, 2, 665. It's off about 1 thousandths too. You'll get a few thousandths error in this on a long measurement there, but you know you can compensate that by using your depth mics on your shoulders there, or calipers, whatever you want to use to make sure you're getting in close. We're going to go to the next shoulder. It's going to be 7.250. That's our finish anyway. So, all right, that makes 3 inches. 4, 5, 6, 7 inches. All right, 100 thousandths, 200 thousandths, 250. So that's our 7 1/4 length. That blended in good. Yeah, we usually touch the diameter and drop it in just a few thousandths there as well. All right, just need some polishing. Chamfers, this end's done. I got this end finished up. I did move the steady down here and hold it to recut that radius. It was getting a little bit of chatter marks in there I didn't like, so I just recut it. All right, and we got this finished up. So this is your gear fit, which is this finished at 4.756 inches. And a question that I always get is a proper interference fit for a shrink fit, things like that. So let's talk about that for just a second. 4.756 is what this measured out at right here. So here's the old shaft, and it measured out good, 4.756, and I ended up making it the same. Let's look at the gear. So this is the gear that goes on there, and this bore right here, it's a good bore. It measures out at 4.751. Okay, so what that's going to give us is a 5/1000 interference fit on this shaft right here. So it'll get shrunk, the gear will get heated up, and it'll drop it in. But the question that I'm usually asked is, how much interference fit do we give these? And a lot of times the guys will tell me what they want on an interference, but as a general rule of thumb, if you don't have anything to work off of, you calculate 1/1000th per inch of diameter. So this is real close to 5 inches. I mean, you can do the math and figure out that it would be 4.7 thousandths interference, but we just went with a equal amount of 5/1000 shrink fit on it. Half a thou over. Perfect. Hit that with some 400, bring it right on down to size, 4.5. I just finished the bearing fit here. This is your shaft fit, seal journal, which is the same, and your bearing fit. And I've tried to hit these at 4.503 to give myself approximately 1/1000 that I can polish it. .503. That looks like it's dead on it too. So 4 inches, 503. We got both of our journals the same. Very good. All we got to do is turn this one to size, cut our radius, chamfer, lathe work will be done. Alright, there we go. There we have it finished and blended in good. I had left myself 5/1000ths on the shoulder right here to be able to clean that up, and then we'll go in there with some emery rolled up and polish that out to a nice looking finish. I just finished putting the final polish on this end right here using a 400 grit paper. Got this polished in real good right there. I don't know what I did with my sandpaper. Again, I just rolled up a little ball, stick it in there, and then polish it out with some 400. So 4.5, 4.503. Okay, we're at 4.5. Try not to scratch the surface there with the carbide face. 4.5. .503. So we hit our journal sizes that we want. It looks pretty good. So lathe work is done, and all we got left now is got a mill a key here, mill a keyway right there. Getting the first keyway started now. That's going to be a 1 inch wide by 1/2 inch deep keyway. I'm using a freshly reground 3/4 inch roughing end mill. Just got a box of them back from, we use precision grinding over in Mobile. I sent a bunch of those roughing end mills over there and they cut them for me, so that was doing real good. So what I do is I rough it out, usually leaving within about 50 thousandths on each side, and then I'll go in there with, say, like a 1 inch end mill to finish it to size and finish the depth to size. I'll get the depth within about 50 thousandths also. Right there we're 1/2 inch deep on just touching off the very top of the radius, and just move down a 1/2 inch, and then we'll offset it to each side to rough it out real close. Just running 160 RPM and feeding 2 inches a minute. Taking it nice and easy. So we got a new 1 inch 2 flute end mill in there, and we're making our finished pass through there. I was going to show you a few of the shafts that I've been working on. There's one there installed in the gear, just kind of staged up, ready to be built. There's one that he just finished building. It looks like it's getting ready to go to paint. That was one of the shafts there. And then that one there, the 10 inch vertical output installed in the gear. Got some LPS3 on there just to keep it from rusting. He's got that one ready to put together pretty soon. So you're getting ready to build this one now, aren't you?
Yep.
And you can see how clean everything is. These things are like new or better whenever they go out. Just showing you the final fit of that 1 inch key. There we got a 1 inch gauge block. It's got a nice firm fit in there. You can move it around. And we got our adjustable parallel in there, and being real careful not to slice ourselves open on this cutter here. And we are showing 1 inch on our mic right there. Alright, so there's our finished 1 inch key there. And again, we've got one more to put right in there. It's turning out real good. But it is quitting time. And tomorrow is Thanksgiving, and we're all ready to get out of here. So this is going to wait until Monday when I get back. So I'm heading out of here and getting ready to enjoy me a 4-day weekend. See you guys later.